Alright, math friends, welcome to this newest video, Greatest Common Factors with Variables. So, in our previous videos, we talked about the greatest common factor and the shortcut with numbers, but what if we tried to find the greatest common factor with variables? For example, what would the greatest common factor be between x squared y and xy? What would the greatest common factor be? Now, it works exactly the same way. You're trying to find the greatest factor that they both have, the greatest common factor, basically. So, let's go back to our easy method and say, what are the factors of x squared y? X squared y is basically x times y. And xy is just x times y. Basically, you could rewrite this here as x times y times x. And this here is going to just be x times y. So the greatest factor, common factor, would be xy. Now, what if you had a few more variables and maybe a little less simpler example? Let's look at another example. Let's choose what is the greatest common factor between x cubed y squared z and x squared y cubed z squared. Now, this may be like, oh my god, there's too many variables, too many numbers, what are we going to do? But let's just solve the problem logically and basically. So, we want to find the greatest common factor, which means these numbers both have to have. In x cubed and x, if we separate here, let's make a line and just separate them one by one. Between x cubed and x squared, both have x squared as a factor. So if both have x squared as a factor, then x squared has got to be a factor of both. But it's not the biggest one because there's still y and z, so let's take those into account. Between y squared and z cubed, they both have y squared. Y squared is the greatest common factor between those two. And between z and z squared, z is a common factor. So here we have x squared y squared z as our greatest common factor. Because both numbers have x squared, both numbers have y squared, and both numbers have z. And both numbers have the maximum that both have is going to be x squared. The maximum y's that both have is going to be y squared. And the maximum number of z's they have is z, because one has z and one has z squared. Alright, let's do one last example. What is the greatest common factor between x, y, z to the power of 4 and x squared y to the power of 4 z squared? I suggest you pause the video, try solving it on your own, and then we'll check our answers. Okay, so let's do this exactly the same way. Let's split it between the x's, the y's, and the z's. Between x and x squared, the biggest number we can take of x's would be x. Between y and y to the power of 4, the biggest number of y's we can take is just y. And between z to the power of 4 and z squared, the biggest number of z's we can take would be z squared. So our greatest common factor is going to be x, y, z squared. Alright, see, that wasn't so hard. See you next time.